So here we go with quadratic word problems, part 1. Now, I hope you realize that all the work we've done up to this point with quadratic equations was for a point. We're going to be building up to this, and everything you do is going to involve either standard form, in which you're going to need to use the quadratic formula or find the y-intercept, or something along those lines. Standard form is very practical for those things, or you're going to need vertex form. And that's why we've done all those practice problems where we're converting between the two, where you're going from one to the other, because sometimes it might give you the problem in one and you have to go to the other, or vice versa, and you need information that's buried in the other form. And so one of the things that people really struggle with the most on this is which form to put it in and how to really attack the problem. So I'm going to go through the first couple problems relatively slowly because I want you to understand how to attack these problems and not panic when you see them. A lot of times people will read one of these problems and they completely freak out because they don't go one small piece at a time. So when I read this first problem, we're going to stop after about every 3 or 4 words actually. So here goes. Number 1, a rectangular pool. Stop right there. Draw it. Before we get too crazy, let's draw it. We have, number 1, a rectangular pool. Okay. It has a length that is 2 more than its width. Okay, let's start drawing that. Now we can argue about whether this is the width or this is the width, and it looks like this is the width. Who really cares? In the end, the formulas are going to work out the same. And based on the way, personally, I've drawn mine, this one looks longer, obviously it is, and so we're going to let that one be the longer one, which in this case is the length. I don't care which way you label this. But if the width is x, then the length is 2 more than that. And generally when I ask students, okay, 2 more than x, what is it? And they wind up saying 2x. That's 2 times x. It's not twice the width, it's 2 more than the width. I know that, you know that, but I wanted to make sure that everybody knew that. Okay? A 5-foot sidewalk is poured around the pool, bringing the total area of the pool and the sidewalk to 440 square feet. What are the dimensions of the pool? So let's just dissect that second sentence. We have a 5-foot sidewalk and it's poured around the pool. I'm going to switch colors here so it doesn't all run together. There's our pool. See? There's the waves in it. There we go. And then there's this person in there, and they're real suntan. We're going to draw them red. And they're popping up out of one of the waves, and there they are. They look like they're drowning. That's not a good thing. Okay, then we're going to draw a, my voice just cracked, didn't it? We're going to draw a sidewalk. And it's going to go around this thing. Let's read the sentence again and make sure we've drawn it correctly and we label it right. A 5-foot sidewalk is poured around the pool. So it's 5 feet all the way around. So this is 5 feet, and this is 5 feet, and this is 5 feet, and this is 5 feet. And so now we have this beautiful picture with a person that's splashing in the waves, and we need to do something with this. Clearly we're going to be finding x. It says the total area of the pool and the sidewalk is 440 square feet. Oh my goodness, how in the world do we do that? Here goes. Let's switch back to blue for a second. The total area, and area for a rectangle, of course, is length times width. We all know that. So how long is that right there? How long is that? Well, let's see. Let's take it one piece at a time. It's 5 feet, and then it's x feet, and then it's 5 more feet. So what we really have is 5 and 5 and x. So we really have x and 2 5s, so we really have 10. You got that? You want me to say it again? If you want me to say it again, rewind the video. Here we go. We're going to find this one. Some of y'all might be a little bit ahead of me on this at this point, and that's fine. Let's find this entire distance across here. I'm going to write this one out a little bit differently. That one's 5. That's x plus 2. And that's 5. And we're going to add all these together. And here we go with the like terms. So that's really x plus 12. Okay? I'm going to erase that. My eraser is clear across the room. I have to walk out of the camera shot to get it. So we're going to multiply length times width, and we're going to get the area. So let's go ahead and do that. The length is x plus 12. Again, if you want to call that the length and that the width, it's in the end, the math is going to work out the same. Okay, now, I'm just getting crooked here. What's the area? Well, they told you the area is 440. 440, and knowing that that's 440, we'll be able to solve that quadratic equation. Well, is this in vertex form or standard form? Neither. That's right. I hope you said neither. You probably sat there with a confused look on your face. It's neither. It's not vertex. The vertex is not staring you in the face. It's not standard form. Standard form is in the form like ax squared plus bx plus c. It's all in order. Every term is lined up with exponents in descending order. And this is neither one of them. And so we have to get this in a form that is solvable. So question, do we need the vertex of this thing? This is where we have to decide what form we need it in. Do we need it in standard form or do we need it in vertex form? Okay, I'll go ahead and tell you we don't need the vertex. Vertices, that's plural for vertex, vertices are maximums and minimums. And we don't need the maximum or the minimum. If it said find the max, minimum, whatever, we would find the vertex. But what we're finding is the area. We're finding x. We're solving for x. If we graphed it, it would be in terms of finding the x-intercepts. But it's not technically graphing. We could go with that approach. That is one way of solving it. But let's go with the quadratic formula. But before we ever touch the quadratic formula, we need to clean this thing up. Let's just go ahead and go real fast. Oops, 440 equals x squared, 10 and 12 makes 22, and 120. We're going to subtract 440 from both sides. Why am I showing this step? I don't know. You're in pre-cal. You can do this. X squared, 22x, and negative 320. All right. I'm going to grab a calculator, and we're going to solve this thing using the quadratic formula. You could just use negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Oh, negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Hey, let's grab a trusty calculator here. Don't wait on me. You go ahead and do it without me. 22 squared minus 4 times 1 times negative 320. Why did I even type that and multiply by 1? I don't even know. Negative 22 plus or minus the square root of 1764. All divided by 2. All right, let's keep going. 1764 should be a perfect square, and it is. By the way, in the process of doing these word problems, we will possibly encounter decimals. I know on the next worksheet we're going to do, we will encounter decimals. Go with it. It's fine. Let's not put things in simplest radical form for this, because when we're finding the length of a swimming pool, we don't say, well, when you make my swimming pool, make it 5 times the square root of 3 meters long. No. We would do that if we wanted an exact measurement. But, you know, when we're actually going to pour the swimming pool, we need feet. We don't need square roots. So, long story short, when it comes to these word problems, final answers need to be in decimals. So, we have negative 22 plus or minus 42 over 2, and we got a whole bunch of stuff here. You're probably thinking, hey, we can reduce. Yeah, sure, whatever. We can. Let's not. We're going to have 2 answers. One of them is what we get when we add. You can see where that's going. And one of them is what we get when we subtract. And I want to point out something here. What we get when we add is positive. What we get when we subtract is negative. Have you ever seen a negative length? No. I've never seen a negative length. Not on a swimming pool. Not anywhere. You can't have a negative length in the real world. And so when we get our 2 answers, 10 and negative 32, you got to be practical. You have to realize this is a swimming pool. The answer is 10. So, let's get the final answer. What are the dimensions of the pool? Now, dimensions, plural. They're not just asking for 10. X is 10. So, the pool, I'm going to write it out as a sentence because that's what I do. The pool is 10 by, 10 by what? Okay? Now we're dealing with the pool. That's, in my picture, it's the black rectangle. The entire area, sidewalk and all, goes around here, but just the pool is x and x plus 2. Well, if x is 10, then x plus 2 is 12. Now, we're so used to doing math, we look at that and we say, oh, that's 120. Sure, yeah, it is. but we're giving the dimensions of the pool, so it's a 10 by 12 pool. Okay, there's number 1. Number 2 is incredibly good. Let me get my eraser. You know what? It was right here the whole time. I thought it was clear across the room. I grabbed it before I even started. Okay, number 2. It's going to be a little bit different. The lengths of the sides of a right triangle are 3 consecutive integers. Even integers. What are they? Oh my. Okay, this is going to get crazy. Don't panic. Don't panic. Let's draw a picture. Let's draw a picture of what? Right triangle. There's some geometry involved. So here we go. Number 2. We have a right triangle. Okay, I almost put 30, 60, 90 out of habit. It's not necessarily. No, we don't know that for sure. Actually, we do know that it's not. And real briefly, let me tell you how we know it's not. It's 3 consecutive even integers. Because they're integers, if this, don't write this down, if this was a 30, 60, 90, then this would be some number 5. This would be 5 square root of 3. That's clearly not an integer, so this can't be a 30, 60, 90. Just saying. Okay, so we have 3 consecutive even integers, and they are forming the sides of a right triangle. Okay, well, let's find out what they are. Well, let's think of 3 consecutive even integers. I'm not doing a guess and check method. You could if you wanted to. But let's think of 3 consecutive even integers. 2, 4, 6. 10, 12, 14. And you can kind of go with that. You can sort of figure out the pattern. If I had 3 consecutive even integers like 2, 4, 6, or 10, 12, 14, I hope it would be kind of obvious how you would continue the pattern. I mean, duh. I would be adding 2 every time because they're even, and I'm adding 2 every time. Interestingly though, if it was odd, I'd still be adding 2 because they're spaced 2 numbers apart. I digress though. So I want 3 consecutive numbers that can go here, here, and here that would make a right triangle. So I mean, we can experiment and we can have like 4, 6, 8, and then we can have 6, 8, 10, and we can have all kinds of crazy stuff, but let's just go ahead and define it using a variable. If the first number, let's erase a little bit here. If the first number is equal to x, we have a list of 3 consecutive even integers, and the first number is x, then what's the second number? Well, if that's even, then the next even number is 2 more than that. X plus 2. And then the third number is x plus 4. Okay, well, what in the world? Where are we going to put them? Let's put them right here in our triangle. X plus 2, x plus 4. Hey, Mr. Reader, how'd you know to put them there? Well, thanks for asking. I know since this is the hypotenuse, it's the longest side. And just based on the way I drew it, that one's the shortest and that one's in the middle. Okay, where do you want to go from here? What do you think? Sine, cosine, tangent? Ah, none of them! Ha, trick question. It's not sine, cosine, or tangent because we don't have enough angle information to figure out that. So we're not going to do anything with sine, cosine, and tangent. When you think of a right triangle, often your mind should go towards right triangle trig, sine, cosine, tangent. Or, let me give you a big fat hint. When I start writing this, you'll understand it. There it is. You're whispering it to yourself. You're sitting there staring at the screen right now going, don't worry, your sound is working. I was just lip syncing. It's Pythagorean theorem. So let's just plug some numbers in. A, B, C. Now it doesn't matter where you put the A and the B. But there's x squared. It does matter where the C is though. Equals x plus 4 squared. Okay, don't mess up. Don't be fooled. You got to FOIL. FOIL, obviously you don't have to FOIL. X squared plus 4x plus 4. We're going to FOIL so much you're going to get sick of it. X squared, actually you could never get sick of foiling. That's completely impossible to do. Okay, wow, we got a mess. It's a big quadratic mess, but it's a beautiful mess. So, let's stop right here. Is this in vertex or standard form? Ha! Neither. Good answer. Not only is it neither, we have to decide now which form do we want it in. Is it asking us to solve for x? That would be standard form. Or is it asking us for a maximum or minimum? That'd be vertex. Actually, it's asking for neither. I lied. It's asking us to solve for x, but it's implied in the problem. So it says, what are the lengths of the sides? What are they? Well, I need to know what x is, so I'm solving. So I better put it in standard form. So I'm going to set my paper down, and we're going to start solving. Like terms go together, I'm going to go fast. 2x squared plus 4x plus 4 equals x squared plus 8x plus 16. Going to subtract, going to do it in my head. I hope you're not offended. We're going to subtract x squared to the other side. So 2x squared minus 1x squared gave me 1x squared. 4x minus 8x is negative 4x. I'm subtracting. Everything's coming to one side. 4 minus 16 is negative 12. There we go. It is now equal to 0. We can use the quadratic formula, but wait, there's more. You can also solve this one by factoring. Actually, number 1 was solvable by factoring as well. So here it goes. Equals 0. X. Two numbers multiply to give me 12 when the two numbers multiply to give me negative 12 and I multiply them, I get a negative 12, and I add them, I get a negative 4. Yeah, I hope you noticed that. So we have two answers. One of them is the opposite of that. This might be the last time I ever write this step, because when it's equal to 0, you end up changing the sign. Here's the other one. There we go. So we're dealing with the length of the side of a sign. I said that wrong. We're dealing with the length of the side of a triangle. There it is right there. It's not negative. It's not that you can't have a negative length on a triangle. Hey, how long is that triangle? Well, it's negative 2 feet. No, it's not negative 2 feet. Oh, no. It ain't negative. Psh, no. Stupid answer. Okay, final answer. What are they? They are 6. What comes after 6? Don't say 7. What comes after 6? Because they're consecutive and they're even. So x plus 2 would be 6 plus 2, obviously 8. Next one after that is 10. 6, 8, 10. That was number 2. You ready for number 3? You're not? Too bad. We're going to do it. Ooh, this is a good problem. This is a challenging problem. This is a very challenging problem. So let's do it. Number 3, we're going to have a rectangular field. We're going to fence it on all 4 sides. Okay, let's draw it. We'll set this thing down and start drawing. Rectangular field is going to be fenced on all 4 sides. Here is number trace. That's 3 in Spanish. Rectangular field. Fenced in on all 4 sides. That is slightly crooked, but we'll go with it. There's probably cows in there. That's a turtle. That clearly is not a cow. Oh well. That one's Raphael. There we go. Teenage Mutant Ninja Turtle. You're going to be fenced on all 4 sides. There will also be a line of fence across the field parallel to the shorter side. Whoa, translate, Mr. Reader. Okay, that's the shortest side. And we want another one that's parallel to it. Now, clearly it's not going to go like there. It's going to go there or there, because it's going to kind of split this thing. Let's split it in half. We're going to erase Raphael. Sorry. We're going to put it here. And I'm going to put it in the middle just because I feel like it. And it actually doesn't matter. In the end, it's going to work out. 900 meters of fencing are available. What dimensions of the field will produce the maximum area? And what is the maximum area? Well, let's find out. My goodness, this one's a mess. This one's crazy. We have 900 meters of fencing available. We're going to build this. And we're going to have 900 meters to do it. So this length plus this length plus this length, they're all the same. Plus this, plus this, plus this, plus this is all equal to 900. Let me say that again. For those of you that are already writing your equation, you might be doing it a little bit different than I'm going to do it. It's not wrong. I'm going to find a slightly easier way just based on experience. But let's take that entire thing as one length, and we'll call that one y, and we'll call this one, obviously, call it y also. That looks like the symbol for Batman. So far this problem's had Ninja Turtles and Batman. There's going to be a car chasing this problem by the end of it. So, all of these distances added together equals 900, because that's how long of a fence we have available. So we have 3 x's and 2 y's, and we can get 900. Okay? Well, what are you going to do with that? I don't know, it's a mess. Well, it says we want to enclose, let's see, what did it say? Maximum area. So not only are we dealing with this, we're dealing with the area. Area of what? What shape is this again? Stop and think about it, okay? Don't panic. I don't know what to do. Okay, area. Area of what? A rectangle. Length times width. X times y. Okay, it's a mess. And we don't know what to do with it yet, but I think we should just go ahead and start solving it, whether we know what to do with it or not. Let's solve for y. Why, you might ask? It's kind of a long answer. Let me tell you what went through my head. We have 2 variables here, and we have three variables here. We technically have 3 variables. We're going to ignore the a for just a second. But we're going to solve this like a system of equations. And back in the day, you had a teacher somewhere that said, well, when you're solving a system of equations, you can use substitution. And they would do these crazy things like this. And then they would divide by 2. And then they would do this, and they'd have 450 minus, should I use a decimal or a fraction? I'm going to go with a fraction. I'm feeling fractional right now. There we go. They would solve this, and then they would plug it into the other one. I hope that looks slightly familiar, because this is substitution. We're solving a system with substitution. We do it all the time in math land. That such a place does not exist. So here's what we're going to do. We're going to put a equals x times y. Well, we know what y is now in terms of x. So we have 450 minus 3 halves x. My goodness, Mr. Reader, where in the world are you going with this? Let's just stop right here. And we'll ask ourselves, what did the problem say? It said find the maximum area. Maximum. Clearly this is not in vertex form and it's not in standard form. And even so, clearly we don't have a y anymore, we have an a. But we're gonna treat that like the variable y, okay? Don't panic. This is almost like y equals blah 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 blah, okay? Let's just go with me on this one. Trust me, I'm going somewhere. Is this in vertex or standard or neither? Neither. Okay. What do we need? Do we need to solve for x, or do we need to find a maximum or minimum? We need to find a maximum, which means we need this in vertex form. So let's put it in vertex form. Okay? Here goes. A equals, I'm aiming for vertex form. Before I put it in vertex form, I should probably put it in standard form and then work my way up to vertex form. That was my working my way up to vertex form dance. 450x minus 3 halves x squared. You probably can't see through my shoulder, can you? There we go. That's still not, I mean, it's sort of standard form, sort of not. Let's divide those up. A equals, let's put this in order. Negative 3 halves x squared plus 450 x. That is now in standard form. You have A, you have B, and you have C. Now, out of habit, some of you might start writing the quadratic formula. No, we're not solving. You know why? Because it's not equal to 0. Ooh. We're going to put this in vertex form, and putting it in vertex form will tell us the, guess, vertex. Good call. that gives us the maximum. Let's pause right here and talk about what the meaning of life is. Not the meaning of life, but let's talk about the graph for just a second. The graph of this equation is upside down. It normally would be a parabola that goes like this, but because it's negative, it goes like this. And it's somewhere probably around in here, which means its vertex is a maximum. And if I can find that vertex, I will find the maximum. I will find the x and y that maximize that area. All right? This is what separates the men from the boys and the women from the girls and the regular turtles from the Teenage Mutant Ninja Turtles. Okay, so in the process of finding the vertex, we need to know this, which is negative b over 2a. Wow, you still can't see through my shoulder, can you? That must be frustrating for you, for me to be standing like right in front of everything. There, let me try it that way. I need to learn to write like this. That would be awkward though. Okay, so we have that, and it's equal to negative 450 over 2 times negative 3/2. My word, what a mess we have down there. We got this. We got this. 2 times negative 3/2, well the 2's are going to divide out. And we have negative 450 over negative 3. 450 divided by 3 is 150. 150. Okay? H is 150. What does that tell me? That tells me half my vertex. That's what that tells me. You know what H is? Do you know? Do you know what H is? H is the x-coordinate of my vertex. Okay, let's keep going. The best way to find K is f of h. Plug it back in right there. So negative 3/2 times 150 squared plus 450 times 150 plus 0. And we get an answer. I don't know that answer, and you don't either. You might have beat me to it, though. That'd be great if you did. Negative 1.5 times 150 squared plus 450 times 150. Wow, that's a big number. That is an unrealistically big number. I'm beginning to second guess myself. Hey, I've made mistakes before. Just ask my ex-wife. I'm just kidding. It's that awkward silence where you're like, wow, he's kind of hesitating, and this is a video. Should I fast forward or not? I'm going to go with it. I'm pretty much positive this is correct. Actually, give me another second to glance through it. I would pause the recording, but it would start a whole new video, so let's not do that. Just checking through my work. See, if this was happening in class, someone would have started humming the Jeopardy theme song. I love that. That's my favorite show. But I hate that song. It's my least favorite song ever. Am I correct? Yes, I am correct. I am correct. I was thinking about it in the wrong way. I was thinking about it wrong. I got 33,750. Whoa, Mr. Reader, that's a big answer. Yeah, it is. That's it. You know what that is? And here's why I thought it was wrong. That's the area. What? Mr. Reader, tell me that again. 150 what? Meters. 33,750 what? Meters? Huh. Yeah, that's 33 kilometers. That's pretty daggone far. This is the area. This is square meters. We still haven't found y. Okay, let's read the problem, make sure we're on the right track. This is a fun one, I tell you what. Just trip my trigger. What dimensions of the field will produce the maximum area? What is the maximum area? Well, we just found the maximum area. So while we're at it, let's go ahead and label it. Let's just call it what it is. Maximum area. Again, how did I know that? Because I was finding the other part of the vertex. Vertex. And in finding the other part of the vertex, what we were doing is plotting x against the area. So when we found that, we found the x that gives us the biggest area. We still haven't found the y that gives us that area. Easy way to find it. Super easy way to find it. Actually, two easy ways to find it. We can do this divided by this, and it will give it to us. Or we could plug that in there, and it should give us the same answer. Let's plug this in here. So we're going to come back over here for just a second. Y equals 450 minus 3/2 times times x, which is 150. And let's see, 450 minus that's 75. 450 minus 75 is 375. I'm going to verify that that is the correct answer with the other method. If it's not, then I'm probably going to get really upset and cry right here on camera. It was wrong. It was wrong, but here's the reason why it was wrong. I was doing the math wrong in my head. I took half of that when I should have taken 3/2 of that. So, anyway, it works out in the end. My goodness, I have fun. I dropped my calculator too. I had a hard time with this problem. I know what I'm doing. I'm having a hard time explaining it. I know what I'm doing. Yeah, you keep telling yourself that. So there we go. We've got the dimensions of the field, and we got the maximum area. See how long this video is running so far. 31 minutes. Let's see. I think I have time for one more problem. Oh yeah, I'll try to squeeze this one in just a couple minutes. This one won't be long at all. Number 4. Then I'll probably make another video for the second half, the back half of the sheet. Lucky you. Actually, I may not. I might let you try it on your own, because y'all are smart people. Number 4. A triangle has an area of a triangle, let's go ahead and write the formula, 1/2 BH of 28 square centimeters. Oh, okay, pause right there. What's the area? 28. Okay, the altitude is 1 centimeter longer than the base. Well, if here's our base, if this is the base and it's x, then the altitude is 1 centimeter longer, so we have x plus 1 right here. Let's fill some numbers in. 1/2 base times height. Mr. Reader, how do we solve that? Oh, first of all, do we solve it or do we put it in vertex form? It never asks for a maximum or minimum, so we're going to solve it using the quadratic formula or factoring. Let's just simplify it a little bit first. We have 28, 1/2 x squared, 1/2 x times 1 is 1/2 x. Oh, Mr. Reader, I don't like those fractions. Hey, I don't either. I love fractions normally. I'm a huge fraction lover. But let's multiply everybody by 2 and it'll wipe out those fractions. It will make it easier. As much as I love fractions and I hate to see it go, we're going to do this. X squared plus 1x. Move that 56 over. You know what? I'm not filling the quadratic formula right now. I'm filling the factoring instead. So let's factor. 2 numbers multiply to give me 56. That will be 7 times 8. Which one's positive? 8. -7. Which means x equals -8. X equals +7. Alright, let's do it. What are the base and altitude? Well, the base in this case, well, I'm freestyling. The base is, well, not negative. It must be 7. And the height, the altitude, is x plus 1. So 7 plus 1, which is 8. It did not ask for the area, because they gave us the area. There we go. There's the front half.